Hello, this is Mr. Molo for lesson 4-3, writing functions. So we got a couple different things that we're doing today. So one is going to be identifying independent and dependent variables. Another one is going to be writing the equations for function notation and putting in the input and output values. So I think we kind of talked about this a little bit the other day, what a function was and how we might have called it something different when we were younger. Some of us might have called it a function machine or an in and out box, something like that. So this is what I'm talking about. So what happens if you put a number in and a number comes out? What's happening to that number while it's inside the machine? So if I have something like this, for every x, I need to find something that happens to all the x's to make it equal y. Okay, it's important that you're looking at all the x's, not just that first one. If I would just say y equals x minus 4, well, yep, that works for the first one because x is 5 and y is 4, so x minus 4 is 1. But does that work with the second one? 10 minus 4 is not 2. So you have to think about which works for all of them. And the one that would work for all of them is x divided by 5. Okay, so 5 divided by 5 is 1, 10 divided by 5 is 2, 15 divided by 5 is 3, and 20 divided by 5 is 4. So you're writing the rule that works for all of them. Okay, if I have something like this, same thing. I need to make sure I'm looking at all what works for all of them. It could be adding, subtracting, multiplying, dividing. So again, you just got to try out different ones. If you think it's adding, those are pretty easy to eliminate because you try the first one. Well, 1 plus 2 is 3, but 2 plus 2 is not 6. So you know it can't be adding. So you know it has to be something with multiplying. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. So it is multiplying by 3. So y equals 3 times x for my rule. Okay, same thing here. This one kind of gives us a big hint here with this 0. Okay, there's only one way to get to 0. You can't add, or you can't multiply or divide to get to 0. That's not going to happen. So you know the only way to get to 0 is by adding or subtracting. Okay. And so let's look from 3 to 0. The only way to get from 3 to 0 is by subtracting 3. Well, let's see if that works for all the other ones. 1 minus 3, yep, that's negative 2. 2 minus 3, yep, that's negative 1. 4 minus 3, that is 1. So this one is going to be x minus 3. If you don't know where to start, if it has a 0 there, that's a really big help because the only way to get to 0 is by adding or subtracting. Okay. The other part is independent, dependent variables. Okay, you probably talked about a lot of this in science class. With math, it's more about probability and seeing what affects the other one. So an example of an independent situation would be like if I flipped a coin. Well, if I got heads the first time, I should get tails the second time because there's a 50-50 chance. But the coin doesn't know that. The coin doesn't have a brain. It's not thinking about, you know, oh, you got heads the first time, you should get tails the second time. It doesn't think about things like that. It's independent. You could get heads twice. You could get tails twice. Dependent is if the thing that happens before it is depending on what your selection is. If I tell one person to pick a card from a deck and they select the ace of spades, well, if I tell the next person to pick a card from the deck, well, they can't pick the ace of spades because the other person already has it. Like desks in the room. You know, if you're the first one in the room, you have 31 choices on where to sit. But if you're the second one in the room, you only really have 30 choices on where to sit. And if you're the last one in the room, you only have one choice on where to sit. So, you know, picking out your desk is something that depends on what happens before you even get there. Okay, so we're going to go through some situations. So a painter must measure a room before deciding how much paint to buy. Okay, so what's going to be the independent, dependent here? Okay, so the amount of paint depends on the measurement of the room. Okay, so dependent is the paint. Independent is the room. Okay, the room isn't magically going to change its shape. If you want to paint your bedroom, it's not going to get smaller because you want to paint it or get bigger. But the amount of paint versus you painting your bedroom or your brother or sister painting their bedroom might be different because of the size of the room. So the amount of paint depends on the size of the room. And then for this example, it's talking about a candle. So the height of the candle, decreases d centimeters for every hour it burns. So for something like this, we are looking at the height of the candle depends on the number of hours it burns. Okay, So if we have a short candle, it's not going to burn very long, but if we have a tall candle, it will burn for quite some time. Let's get to ones where it talks about some money. Alright, so let's do an amusement park charges $6, parking fee plus $29.99 per person. So here, you wrote it out. If you're going with X amount of people, you can figure out how much it's going to cost you. So the cost depends on how many people you are bringing. So how many people are in the car with you. If you have 5 people in the car, it's going to cost you a lot more to go than if it's just you and a friend. So the cost will depend on how many people you have going.